Welcome back, everyone. So we're still discussing solving systems of linear equations by using the graphing method. So these are the examples that I suggested you did on your own, and I will quickly go over the solutions. So the first equation or system of equations is 2x plus y equals 5 and x minus 2y equals 10. So we have a little bit of work to do with each equation so we can bring them to slope y-intercept form. So the first one, y will sit by itself in the left side, so it's not switching sides, and 2x has to move to the other side, so it becomes negative 2x. 5 is already on the right side, so it's not going to move. So the equation turns into y equals negative 2x plus 5. We can identify the slope, the number before x, as negative 2, write it in fraction form, negative 2 over 1. The y-intercept is positive 5, so the constant number. In the same fashion, we'll continue with x minus 2y equals 10. So we leave the y term in the left side of the equation. It was in the left, so it's still in the left. So that's why you have a negative 2 as a coefficient. The x term will move to the other side, so from positive x will become negative x. 10 was already on the right side, so positive 10. One more thing to do here is isolate y from its coefficient. This can be easily done by dividing every term on both sides of the equation by the coefficient of y, negative 2. And the equation turns out to be y, so the two negatives here will simplify. Negative x over negative 2 in a simplified form is positive 1 over 2. And 10 divided by negative 2 is negative 5. So this will leave us with this equation y equals 1 over 2x minus 5. Slope of 1 over 2, so rise 1, run 2. And y-intercept of negative 5. Again, you start graphing both lines. You start with the y-intercept. So y-intercept 5 for the pink line. And then you rise negative 2, which means go down to run 1. Down to run 1. Down to run 1. So this will create the line y equals negative 2x plus 5. In the same way, you draw the graph of the line y equals 1 over 2x minus 5. Start from the y-intercept of negative 1. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. And there goes the line. The two lines will intersect at this point. You can identify the coordinates of this point by simply dropping a perpendicular onto the x-axis. That will give you the x-coordinate of the point. And from the point, drop a perpendicular onto the y-axis that will tell us the y-coordinate of the point, negative 3. This will be the solution to the system. In example number 3, again we have two linear equations. None of them are in slope y-intercept form, so we have to work on making into the y-intercept form. 2x plus y equals 6. Y sits on the left side, not switching. 2x goes to the other side, becomes negative 2x, and 6, positive 6 right there. Slope is negative 2. The coefficient before x, we write it in fraction form again, negative 2 over 1. The y-intercept is positive 6. In the same way, we work with a second equation in the system, y minus 8 equals negative 2x. That's what's given. You leave a y in the left side. Negative 2x was already on the right side. Nothing changes for it. And negative 8 will move to the right side. It will become a positive because we are switching sides. So the slope will be negative 2 over 1 and the y-intercept positive 8. We draw both graphs of the line, and surprisingly we see that they will never intersect in here. And we're gonna double check with our slope because we remember mentioning what happens when two lines don't intersect. The two lines will never meet in this case because their slopes are the same, negative 2. Their y-intercepts are different. So that's what makes them parallel lines. And we're going to say that the system has no solutions because the two lines will never have a common point. The last example is example 4. Example 4 has two equations, 3x plus y equals 1, and the next one, 6x plus 2y equals 2. Again, equations are not in slope-y-intercept form, so we'll convert 3x plus y equals 1 into slope-y-intercept by isolating y. So y is in the left side, stays in the left side of the equation. 3x will move to the other side, so it will become negative 3x and then plus 1. The slope is negative 3. We write it in fraction form as negative 3 over 1. The y-intercept is 1. In the same way, we deal with the second linear equation, 6x plus 2y equals 2. We're going to have to isolate the y term, leave it in the left side of the equation, and 6x will have to travel to the right side, so that's why coefficient of 6 becomes negative 6. So the equation in a more simplified form, remember you need to isolate y from its coefficient. We want to have just y in the left side. So we have y equals negative 3x plus 1. You probably noticed by now that the two equations have ended up being the exact same equation once we simplified both of them. And when you graph them, they will be represented by the same line. So as you see in here, you have the pink line underneath the green on top. I try to make them a little bit more visible, sort of. But we can say with confidence that the two lines are on top of each other. In this case, actually, we call them coincident lines, okay? Because the two lines coincide. When this happens, we're going to say that the two lines will have an infinite number of points in common, and therefore we'll say that the system of two linear equations will have an infinite number of solutions. Hope all this made sense, and I hope that you enjoyed learning about how to solve a system of equations by using the graphing method. Once you understand the graphing method, the other two methods will